Mars, the red planet, a world that has captured our imagination for centuries. Even with our most advanced rovers scanning its surface and orbiters mapping every inch from above, Mars still holds secrets that defy explanation. Think about that for a moment. We've sent robots to drill into its soil, analyze its atmosphere, and even listen to its winds. Yet some discoveries leave scientists scratching their heads, wondering what else is hiding in those vast, rusty deserts. It's a place where the more we learn, the more questions we uncover. Picture this, a landscape where strange lights flicker in the distance, where rocks seem to move on their own, and where geological formations appear too perfect to be natural. These aren't scenes from a sci-fi movie. They're real phenomena observed on Mars, and no one can fully explain them. Some of these mysteries hint at the possibility of ancient life, while others suggest forces at work we don't yet understand. And that's what makes Mars so thrilling. It's not just a distant world, it's a puzzle waiting to be solved, a story still being written, with each new discovery adding another twist. Today, we're diving deep into 30 of the most baffling enigmas Mars has to offer. From towering structures that look eerily artificial to strange seasonal changes that science can't yet account for, these mysteries challenge everything we think we know about the red planet. Some might be clues to its ancient past, while others could reshape our understanding of the universe itself. So buckle up, because by the end of this journey, you'll see Mars in a whole new light, and you might just find yourself staring at the night sky, wondering what other secrets are out there waiting to be uncovered. The first time we saw it, it sent shivers down our spines. A massive humanoid face staring up from the Martian surface, nearly 2 miles long, with what appeared to be symmetrical eyes, a nose, and even a faint mouth. When Viking 1 captured this image in 1976, the world went wild. Could this be proof of an ancient alien civilization? The so-called face on Mars became an instant sensation, fueling endless conspiracy theories, books, and even movies suggesting it was a monument left behind by a lost Martian race. But as technology improved, so did our ability to see the truth. Higher resolution images from missions like Mars Global Surveyor in the late 1990s revealed something far less dramatic. Just an ordinary mesa, a natural rock formation sculpted by wind and time. The play of shadows and low resolution in the original Viking photo had tricked our brains into seeing something familiar, a phenomenon called pareidolia. It's the same reason we see shapes in clouds or the man in the moon. Yet, even with NASA clear explanations and detailed imagery, some skeptics remain unconvinced. They argue that newer images were taken from different angles or under different lighting to downplay the face's significance. Some fringe theorists still claim that the surrounding area, known as Cydonia, holds other geometric anomalies, pyramids, ruins, as if the entire region was once a sprawling alien city. Science tells us it's just geology, an impressive but entirely natural formation. But the allure of the unknown keeps the debate alive. After all, what if we're wrong? What if, buried beneath millennia of dust and erosion, there's something more? That's the power of Mars. It doesn't just challenge our technology, it challenges our imagination. And whether the face is a trick of the light or something more mysterious, it reminds us that sometimes the most compelling mysteries are the ones we might never fully solve. Not far from where the infamous face on Mars was photographed, something just as puzzling dots the landscape, structures so eerily geometric, they look like they were carved by intelligent hands. In the same windswept region of Cydonia, formations resembling pyramids rise from the rusty soil, their slopes oddly symmetrical, their angles precise. When these images first surfaced, it was impossible not to draw comparisons to the Great Pyramids of Egypt. Could these be the ruins of some ancient Martian civilization, buried beneath the dust of ages? Scientists were quick to offer a more down-to-earth explanation. Wind erosion, they argued, can sculpt rock into surprisingly clean shapes over millions of years. On our own planet, we see similar formations like the stark, triangular cliffs of the Matterhorn or the natural pyramidal peaks of the Andes. The processes are slow but powerful, gusts of Martian sand, finer than talcum powder, sandblasting the terrain grain by grain. Over eons, even the hardest rock can be whittled into something that looks almost deliberate. But not everyone is convinced. Researchers outside the mainstream point to the uncanny alignment of these Martian pyramids, noting how some appear to mirror celestial patterns, much like Earth's ancient monuments. A few even claim the largest Cydonia pyramid, dubbed the D&M pyramid after its discoverers, has mathematically perfect angles that defy random chance. Could these be the skeletal remains of temples or observatories built by a culture that once gazed at the same stars we do? Then there's the tantalizing, if controversial, theory linking these formations to something even grander. Some propose that Cydonia's pyramids aren't standalone relics but part of a vast, buried city, with the face as its centerpiece. Satellite images analyzed by independent researchers seem to show grid-like patterns nearby, resembling collapsed roads or foundations. Of course, skeptics dismiss these as pareidolia, again our brains desperate to find order in chaos. The debate rages on, but here's what we do know. Mars was once a very different world. Rivers carved its valleys, lakes filled its basins, and its atmosphere might have been thick enough to shield life. If Earth could birth civilizations against all odds, why not Mars? Whether these pyramids are nature's artwork or something more profound, they force us to question and wonder, and in the end, that's the real magic of the Red Planet. It doesn't just show us rocks, it holds up a mirror to our own longing for connection across the stars. When the Opportunity rover rolled across Mars' Meridiani Planum in 2004, it stumbled upon something bizarre: tiny, spherical stones scattered across the landscape like beads spilled from a broken necklace. Scientists quickly nicknamed them blueberries, not for their color but for their uncanny resemblance to the fruit in size and shape. But these were no ordinary rocks. Ranging from just 1 to 6 millimeters in diameter, their near-perfect roundness and uniform distribution raised immediate questions. How could nature produce something so symmetrical on a planet known for its harsh, chaotic terrain? Analysis revealed the blueberries were made of hematite, an iron oxide mineral that often forms in the presence of water. On Earth, similar formations called concretions occur when minerals precipitate from groundwater, slowly building up layer by layer around a central nucleus. Think of them like geological pearls. Mars blueberries, scientists theorized, might have formed the same way, suggesting this dusty plain was once soaked in liquid water, possibly even a shallow sea. But here's where things get intriguing. Some researchers noted the blueberries' unusual density and distribution, arguing they were too uniform to be purely natural. A few even floated the radical idea that they could be fossilized remnants of ancient microbial life, their spherical shapes preserving colonies of bacteria much like stromatolites on Earth. Others went further, proposing the blueberries might be industrial byproducts, tiny ball bearings left behind by some long-gone Martian technology. Mainstream science dismisses these more exotic theories, pointing to the concrete evidence of water-based formation. Yet the blueberries still hold mysteries. Why are they concentrated in certain areas but absent in others? Why do some appear eroded while others seem freshly exposed? Each answer leads to new questions, painting a picture of a Mars that was once far more dynamic and perhaps far more alive than the barren world we see today. What makes these tiny spheres so captivating isn't just their origin story. It's what they represent, a clue, a whisper from Mars' watery past. They remind us that even the smallest things can hold the biggest secrets, and that sometimes the most unassuming discoveries are the ones that change everything. High above Mars' polar regions, the landscape undergoes a strange transformation. Each spring dark, spindly tendrils stretch across the dunes, fanning out like skeletal fingers or the bare branches of winter trees. Captured by orbiters like the Mars Reconnaissance Orbiter, these eerie formations can sprawl for hundreds of meters, appearing and vanishing with the seasons. At first glance, it's hard not to let your imagination run wild. Could these be signs of some hardy, alien vegetation stubbornly clinging to life in the frigid Martian wastes? The scientific explanation, while less fantastical, is no less fascinating. These so-called trees are actually streaks of dark basaltic sand or dust, sliding down sun-warmed slopes as seasonal carbon dioxide ice vaporizes. Known as recurring slope lineae, or RSL, these flows are triggered by the subtle warming of the Martian spring. The process is almost like a slow-motion avalanche, dry material cascading downhill, leaving behind those haunting branch-like patterns. It's a reminder that even without liquid water, Mars is still an active, shifting world. But not everyone is satisfied with the dry explanation. Some researchers point to the streaks' peculiar behavior, how they darken and lengthen during warmer periods, almost as if responding to some unseen nourishment. A controversial study in 2015 even suggested traces of hydrated salts within these streaks, hinting at the possibility of briny liquid water just beneath the surface. If true, it would mean Mars isn't just a frozen desert, but a place where water, however fleeting, still flows. The implications for potential microbial life would be staggering. Then there are the outliers, those who dare to ask, what if we're seeing something even more extraordinary? A handful of scientists have floated the idea of extremophile organisms adapted to Mars' harsh conditions, whose life cycles could produce seasonal changes in the soil. On Earth, we've found bacteria thriving in acidic lakes, scorching hot springs, and even the vacuum of space. Could Mars' trees be the shadows of some unthinkably resilient life form, spreading and retreating with the rhythm of the seasons? Mainstream science remains skeptical, and for good reason. Extraordinary claims require extraordinary evidence, and so far, the sand and dust theory fits the data best. But the mystery lingers, and that's what makes these streaks so compelling. They're a reminder that Mars refuses to be easily understood. Every time we think we've pinned it down, it throws us another curveball, a whisper of water, a shadow of life, or just another trick of the light. Whether these dark streaks are the work of wind and ice or something far more mysterious, one thing's for sure: they're proof that Mars still has stories left to tell. One day, opportunity was rolling across Mars as usual, snapping photos of the same patch of dirt it had examined weeks earlier. Then, something impossible appeared, a rock roughly the size of a jelly donut, sitting right where nothing had been before. Scientists at NASA dubbed it Pinnacle Island, and it sparked instant debate. How could a rock just materialize on a planet with no known geological activity? NASA official explanation was practical. Opportunity's wheels had likely kicked it up while maneuvering. The rover's movements could dislodge small stones, flipping them into view. But here's the twist: Pinnacle Island wasn't just any rock. Close-up images revealed a bizarre composition, with a red center surrounded by a white rim, like a cosmic candy. Analysis showed it was rich in sulfur, magnesium, and manganese, elements that suggested it had been buried and untouched for eons before opportunity unearthed it. Cue the wilder theories. Some researchers argued the rock was too perfectly placed to be a random kick-up. Could a nearby meteorite impact have launched it into position? Others, diving into speculation, pointed to the rock's odd shape and coloration, suggesting it might be a fragment of something artificial, a piece of machinery or debris. The most fringe voices even proposed it was placed there intentionally, though by whom or what, no one could say. What's undeniable is that Pinnacle Island gave scientists a gift, a rare chance to study freshly exposed Martian material. Its unique chemistry hinted at ancient water interactions, adding another piece to the puzzle of Mars' wet past, yet the mystery of its sudden appearance lingers. Was it really just a lucky flip of a rover's wheel, or does Mars still have ways of surprising us that we don't yet understand? One thing's certain. On a planet where rocks don't just show up unannounced, Pinnacle Island reminds us that Mars keeps its secrets well, and sometimes it drops them right in front of us. The Martian surface is a graveyard of oddities, but few have sparked as much feverish debate as the so-called stick figure, photographed by Curiosity in 2017. Sticking out of the rusty soil like a bony finger, the elongated object bore an unsettling resemblance to a fossilized limb or even a crude tool. The internet erupted. Was this proof of ancient Martian life or some long-lost civilization? Scientists, however, had a far less sensational explanation. The stick was almost certainly a ventifact, a rock meticulously carved into its slender shape by centuries of relentless wind. On Earth, we see similar formations in deserts like the Atacama or Death Valley, where sand-laden gusts act like nature's sculptors, whittling stone into eerie, elongated forms. Mars, with its thinner atmosphere but persistent winds, is even more adept at crafting these geological oddities. Yet the human brain is wired to seek familiarity in chaos, a quirk known as pareidolia. It's why we see faces in clouds or animals in passing shadows. That same instinct transforms Martian rocks into relics of intelligence, tools, bones, even statues. The stick figure is just the latest in a long line of such misinterpretations, from the Mars rat to the alien thigh bone. Each time, the pattern is the same, a fleeting resemblance, a viral frenzy, followed by sober scientific rebuttal. But here's what makes this phenomenon fascinating beyond mere misidentification. The stick figure debate underscores a deeper tension in how we explore Mars. On one side, the rigorous, evidence-based approach of planetary geology. On the other, our primal hunger for connection, to find not just rocks but stories. Whether it's a fossil or just another wind-blown stone, the stick reminds us that Mars isn't just a scientific frontier. It's a mirror reflecting our hopes, our fears, and our unshakable curiosity about whether we're truly alone in the cosmos. In the vast, silent deserts of Mars, where shadows stretch long and the rocks wear the scars of ancient winds, an image from the Curiosity rover in 2015 sent the internet into a frenzy. There, in the grainy black and white footage, a jagged silhouette crouched behind a boulder, its spindly limbs splayed out like a crab poised to strike. The so-called Mars crab monster became an overnight sensation, with armchair experts dissecting every pixel, convinced NASA had inadvertently captured proof of alien life lurking in the red planet's crevices. But science, as always, offers a far more grounded explanation. The crab was nothing more than a trick of light and perspective, a shadow cast by a peculiarly shaped rock, its edges fragmented by erosion into jagged, claw-like protrusions. On Mars, where the thin atmosphere scatters sunlight differently than on Earth, even ordinary shadows can take on eerie, elongated forms. Add in the rover's low-resolution navigation cameras, and you've got the perfect recipe for pareidolia, our brain's habit of imposing familiar shapes onto random patterns. It's the same phenomenon that turns a burnt toast into the Virgin Mary or a cloud into a dragon. What makes the crab monster legend so enduring isn't just the shadow itself, it's the way Mars consistently plays with our expectations. Every few years, another discovery goes viral: the Mars rat, the alien thigh bone, even a spoon seemingly balanced on a rock. Each time, the cycle repeats: excitement, scrutiny, debunking, yet the allure never fades. Why? Because Mars, more than any other planet, feels close. It's a world of deserts and dunes, of sunsets tinged blue, a place that's alien yet eerily familiar. When we see a crab-like shadow or a stick that resembles a bone, it taps into a deeper question. Could something actually be out there? Scientists, of course, urge caution. The crab monster, like so many Martian mysteries, is a testament to the power of context. Without the full landscape, the play of light, or the scale of the scene, our brains fill in the gaps, sometimes with logic, sometimes with monsters. Yet, even as we chuckle at the meme-worthy hype, there's a nugget of truth buried in the spectacle. Mars does hide secrets, just not the ones we imagine. It's real mysteries like the methane spikes that vanish without explanation, or the underground lakes that might harbor microbes, are far subtler than shadow crabs. But they're also far more tantalizing, so the next time you spot a Martian creature in a rover image, remember, the red planet's greatest trick isn't hiding aliens. It's keeping us guessing, turning dust and shadows into a canvas for our wildest hopes, and proving that sometimes the most fascinating discoveries are the ones we don't make. In the barren expanse of Mars' Gale crater, a single grainy image from Curiosity's massed camera ignited a firestorm of speculation in 2015. There, perched on a rocky outcrop, was a silhouette uncannily resembling a seated woman. Her head tilted slightly, her arms resting at her sides, even the suggestion of long hair cascading down her back. The internet exploded with theories. Was this a Martian statue, a fossilized being, proof that the red planet once hosted intelligent life? The reality, as always with these viral Martian anomalies, lies in the interplay of light, angle, and the human brain's relentless drive to find meaning in randomness. Scientists confirmed the woman was merely a small, weathered rock formation roughly the size of a loaf of bread, positioned in such a way that shadows accentuated its humanoid outline. From Curiosity's vantage point, the rock's jagged edges and wind-scoured grooves created the illusion of limbs and flowing hair, a textbook example of pareidolia in action. Similar tricks of perception happen daily on Earth. Think of the Old Man of the Mountain cliff profile or Arizona's famous Elephant Rock. What makes the Mars woman particularly fascinating isn't just the illusion itself, but why these images capture our collective imagination so fiercely. Psychologists point to two primal instincts at work. First, our brains are hardwired to prioritize human faces and forms, a survival mechanism that helps us quickly identify friends or threats. Second, Mars occupies a unique space in our cultural psyche as the most Earth-like world in the solar system. When we see a woman on its surface, it taps into deep-rooted myths and sci-fi narratives about extraterrestrial civilizations, making the mundane momentarily magical. Yet this phenomenon also reveals a tension in modern space exploration. Every few months, another discovery goes viral: a Mars igloo, a gateway, a Star Trek logo, only to be debunked by scientists. Some argue this cycle distracts from genuine breakthroughs, like the discovery of organic molecules or evidence of ancient lakes. Others counter that these illusions serve a vital purpose. They keep public attention fixed on Mars, fueling support for missions and funding. After all, it's harder to ignore a planet that seems to wink at us with riddles, even if those riddles are just rocks and shadows. Perhaps the most compelling lesson here isn't about Mars at all, but about us. The woman figure, like the face or the crab monster, reflects humanity's insatiable hunger for connection in the vast silence of space. We project our stories onto the cosmos, turning barren landscapes into canvases for our hopes and fears. And while science will always ground us in evidence, there's something beautifully human about glancing at a rock on another world and seeing, for just a moment, a face staring back. Nestled among the jagged rocks of Mars' Gale crater, something impossible caught the world's attention in 2015, a gleaming, metallic-looking spoon, seemingly suspended in midair above the Martian surface. The Curiosity rover's images showed it with a curved bowl and a slender handle, as if some cosmic tea drinker had left it behind. the internet erupted with theories. Was this ancient cutlery a fragment of alien technology, or just another trick of the eye on a planet that specializes in them? Geologists quickly weighed in with a far simpler explanation. The spoon is actually a delicate rock formation sculpted over millennia by the relentless Martian winds. On Earth, we see similar structures in places like Utah's Arches National Park, where softer rock erodes faster than harder layers, leaving behind bridges, fins, and even what appear to be stone tables. Mars, with its thinner atmosphere but persistent sandstorms, takes this artistry to extremes. The spoon's handle is likely a fragile outcrop of resistant rock, while the bowl is a hollow carved out by wind-blown grit. Gravity does the rest, making it seem to float when viewed from the rover's angle. But here's why the spoon fascinates beyond mere geology. Its near-perfect balance and symmetry tap into something deeper: our innate tendency to see design in randomness. Psychologists call it intentionality bias, the reflex to attribute purpose to patterns, whether it's a face in the clouds or a spoon on Mars. Conspiracy theorists latch onto this, arguing that such precision can't be accidental. Some even cite the spoon as evidence of a lost Martian civilization, pointing to Earth's own ancient mysteries like the Antikythera mechanism or the Nazca lines, as proof that advanced artifacts can appear shockingly out of place. Scientists counter with cold, hard physics. Mars' low gravity, just 38% of Earth's, allows for far more precarious rock formations than we'd see at home. Combine that with eons of abrasive winds, and you get nature's version of a master sculptor. Yet even the most disciplined minds admit the spoon is uncanny. It's a reminder that Mars doesn't just challenge our scientific tools, it challenges our instincts. Every time we think we've decoded its language, it serves up another enigma, perfectly balanced between the explainable and the extraordinary. So, is the spoon a geological fluke or a whispered clue? The answer, like so much on Mars, depends on where you choose to look through the lens of a microscope or the lens of imagination. And perhaps that's the real lesson here. On a planet where even the rocks defy expectations, the line between science and wonder is thinner than the handle of a floating spoon. Amid the rippling dunes of Mars' Hellas Basin, a shape so uncanny it stopped scientists mid-scroll appeared in images from the Mars Reconnaissance Orbiter, a near-perfect delta symbol, its sharp angles and symmetry strikingly reminiscent of the iconic Starfleet insignia from Star Trek. The internet predictably lost its collective mind. Had Martian winds accidentally etched a tribute to Captain Kirk? Was this the universe's cheeky nod to sci-fi lore? Geologists quickly grounded the hype in hard science. The Starfleet symbol is a textbook example of Yardang's razor-backed ridges carved by relentless wind erosion. On Earth, we see these in places like China's Kadam Basin or Arizona's Painted Desert, where softer rock is stripped away, leaving behind jagged crests. Mars, with its thinner atmosphere and global dust storms, takes this process to extremes, sculpting landforms that look almost designed, the delta shape. Pure coincidence, a fleeting alignment of ridges and shadows that from orbit happen to mirror pop culture's most famous logo. But here's where the story gets richer. The symbol's temporary nature, shifting with the light and seasons, mirrors a deeper truth about Mars exploration. Just as Star Trek imagines a future of interstellar unity, this accidental logo symbolizes humanity's hunger to find familiarity in the unknown. We've done it for centuries, mapping constellations as hunters and beasts, naming Martian craters after earthly poets and scientists. Now we're projecting Star Trek onto a distant dune. It's less about aliens and more about our need to stitch the cosmos into stories we understand. Of course, conspiracy theorists couldn't resist suggesting NASA planted the symbol as an Easter egg. Yet the real Easter egg is how Mars itself plays along, offering these whimsical illusions. Whether it's a crab monster or a Starfleet salute, the planet seems to wink at our fantasies, reminding us that exploration isn't just about data, it's about wonder. And while scientists roll their eyes at Martian trekkies, even the most stoic among them might admit, if you're going to hallucinate a symbol on another world, there are worse choices than one representing curiosity, boldness, and the spirit of discovery. After all, isn't that why we're looking at Mars in the first place? So the next time you see a Starfleet Delta in the Martian sands, remember, it's not a message from aliens. It's a message from us, a testament to how deeply we crave the cosmos to feel like home. And who knows, maybe one day when humans finally set foot on Mars, some clever astronaut will kneel in the dust and etch that symbol for real, because sometimes life imitates art and science fiction paves the way for science fact. Deep beneath the scarred surface of Mars, winding through its ancient volcanic plains like veins, lie strange tubular structures that have fueled both scientific curiosity and wild speculation. Captured in orbital images, these eerie tunnels, some stretching for miles across the landscape, appear as shadowy, snake-like depressions, their ceilings collapsed in places to reveal dark voids below. To some researchers, they're clear remnants of lava tubes, subterranean pathways carved by rivers of molten rock billions of years ago. To others, there's something far more tantalizing, potential shelters for past or even present Martian life. The lava tube explanation is the most widely accepted. On Earth, we see these formations in places like Hawaii's Kazumura Cave or the lava fields of Iceland, where volcanic activity once hollowed out tunnels beneath the surface. Mars, with its history of massive volcanoes like Olympus Mons, likely underwent similar processes. When lava flows cool and harden on the surface, molten rock continues to surge beneath, leaving behind empty tubes once the eruption ends. Over time, sections of the ceiling collapse, creating the skylight-like openings we see today. These tubes could be colossal, far larger than Earth's, thanks to Mars' lower gravity and past volcanic violence. Some estimates suggest they might stretch hundreds of feet wide, big enough to fit entire city blocks inside. But here's where the mystery deepens. A handful of scientists and independent analysts have pointed to oddities in the tunnel's geometry, unnervingly straight sections, junctions that resemble deliberate intersections, even what appear to be branches that defy typical lava flow patterns. These features have led a vocal minority to propose an alternative theory, that some tubes might have been modified or even constructed by intelligence. Could they be remnants of underground habitats built to shield a civilization from Mars' harsh surface conditions? It's a radical idea, but not without precedent. On Earth, humans have used natural caves as shelter for millennia, later expanding them into cities like Cappadocia's underground networks. If Mars once had life, why wouldn't it do the same? The truth might lie somewhere in between. While most tunnels are almost certainly natural, their potential as refuges for microbial life, past or present, is a serious scientific focus. Lava tubes offer protection from radiation, temperature extremes, and even meteorite impacts. Recent studies suggest some might still harbor pockets of ice or even briny liquid water, making them prime targets in the search for extremophiles. NASA upcoming missions like the Mars Life Explorer are specifically designed to probe these hidden environments. Imagine descending into one of these pitch-black caverns, scanning the walls for fossilized biofilms or mineral traces left by long-gone organisms. Of course, not all tunnels are created equal. Some regions, like Arsia Mons near the equator, are riddled with these formations, while others are conspicuously empty. Could this distribution hint at past volcanic hotspots or something more deliberate? Future missions equipped with ground-penetrating radar or even autonomous drones might finally answer these questions. Private ventures like SpaceX have even floated the idea of using lava tubes as pre-built shelters for human colonies, their thick roofs offering ready-made protection against cosmic rays. Whether natural wonders or silent ruins, these tunnels embody Mars' most enduring allure. They're places where geology and imagination collide. Every collapsed skylight is a doorway not just into the planet's volcanic past, but into the tantalizing possibility that, somewhere in those depths, we might find the one thing we've been searching for all along, proof that we're not alone. And until we send robots or humans inside, they'll remain one of the red planet's most compelling enigmas, beckoning us to look beyond the surface and dig deeper. One of the most persistent debates about Mars revolves around a series of rover photographs that, on first glance, seem to show something impossible: fossilized remains. Over the years, keen-eyed observers have flagged images where rocks resemble vertebrae, turtle shells, or even tiny crustacean-like creatures embedded in the Martian soil. The most famous of these, a curved, segmented object dubbed the Martian dragon bone by conspiracy forums, looks startlingly like something that once crawled or swam. At a distance, it's almost too easy to believe we're staring at relics of ancient life, frozen in time on an alien world. Geologists, however, are quick to temper this excitement with cold, hard reality. Those bones and shells are textbook examples of ventifact rocks sculpted by wind erosion into smooth, flowing shapes that mimic organic structures. On Earth, we see similar formations in deserts like Namibia's Skeleton Coast, where gusts laden with sand act like nature's chisel, carving rocks into uncanny imitations of ribs, skulls, and even full animal forms. Mars, with its thinner atmosphere but constant hurricane-force winds, is a master of this illusion. The segmented dragon bone, for instance, is likely just a hardened layer of sediment that fractured under stress, its pieces eroded into those hauntingly uniform ridges. But here's where the debate gets thorny. Even seasoned scientists admit that identifying fossils remotely, especially on another planet, is fraught with challenges. On Earth, paleontologists rely on context, the surrounding rock layers, chemical traces, and microscopic textures that scream biological origin. Mars rovers, for all their sophistication, can't always provide that level of detail. A rock might look like a fossil, but without the ability to slice it open or analyze its cellular structure, if it ever had one, certainty is elusive. This ambiguity fuels theories that NASA is either missing evidence or deliberately dismissing it. Some researchers propose a middle ground. What if these formations aren't fossils, but pseudofossils, mineral structures that form through geological processes yet mirror biological ones? On Earth, we've found manganese oxide deposits that resemble bacteria colonies and silica formations that look like petrified plants. If Mars had ancient hot springs or acidic lakes, similar chemistry could have created deceptively lifelike shapes. It's a humbling reminder that nature often blurs the line between the living and the non-living, especially in extreme environments. Yet the allure of Martian fossils persists for a deeper reason. In the early 1990s, a meteorite from Mars, labeled a LH84001, made headlines when scientists claimed it contained microscopic structures resembling fossilized bacteria. Though later studies debunked the assertion, the controversy revealed how desperately we want to find life, even in ambiguous shapes. That same longing now plays out in every rover image where a shadow or a crack triggers our pattern-seeking brains. The truth is, Mars does hold fossils, just not the kind we imagine. Its real relics are chemical, isotopes locked in rocks, minerals that only form in water, and layers of sediment whispering of ancient rivers. These are the clues that might one day lead us to definitive proof of life. Until then, the dragon bones and shells remain a testament to two things: the incredible power of wind and time to deceive us, and the even more incredible power of hope to make us look twice at a rock and wonder if it's something more. On February 3, 2013, NASA Curiosity rover captured something that sent the internet into a frenzy: a grainy black and white image of the Martian horizon, and there, just above the rugged terrain, a tiny but unmistakable bright light. Not flickering, not diffused, but a stark, focused gleam, as if someone had shone a flashlight from behind a distant ridge. UFO forums erupted overnight. Was this evidence of active technology on Mars, a signal from underground survivors, or, as some fervently claimed, proof that NASA had stumbled upon something it wasn't supposed to see? Scientists at the Jet Propulsion Laboratory were quick to respond. Their explanation, far less dramatic but no less fascinating. The bright spot, they argued, was likely a cosmic ray hit, a high-energy particle from deep space slamming directly into the rover's camera sensor. On Earth, our atmosphere shields us from most of these particles, but Mars, with its wispy air, has no such protection. Curiosity's cameras are bombarded daily, occasionally resulting in these transient, pixel-sized flashes. Similar artifacts appear in images from other Mars missions, like Spirit and Opportunity, often as white streaks or specks, but here's where things get interesting. Not all light anomalies fit the cosmic ray theory. In April 2014, Curiosity spotted another bright spot, this time in 2 consecutive images, suggesting it wasn't a fleeting sensor glitch. Some researchers proposed sunlight reflecting off a smooth rock surface, perhaps a chunk of metallic meteorite or a patch of ice. Mars' thin atmosphere can amplify reflections, making even small, glossy surfaces appear unnaturally luminous from certain angles. Others pointed to the possibility of specular reflection, where sunlight bounces off dust or ice crystals in the air, creating localized bright spots. Yet the UFO community wasn't swayed. Skeptics noted that the light appeared in specific locations, sometimes seeming to move between images. A few even superimposed rover path maps, arguing the lights aligned with rumored underground cavern entrances or artificial structures. The most fringe theorists suggested these were deliberate signals, perhaps from a hidden Martian civilization or even extraterrestrial visitors monitoring our rovers. NASA's official stance remains grounded in Occam's razor. The simplest explanation is usually correct, but the debate reveals something deeper about how we explore Mars. Every anomalous pixel becomes a Rorschach test, reflecting our hopes, fears, and preconceptions. Cosmic rays and sun reflections might explain the mechanics, but they can't dull the thrill of the unknown. That tiny light, whether a particle collision or something more mysterious, taps into a fundamental human question: are we alone? And until we have boots on the ground, turning over every rock and peering into every shadow, the answer, like that distant gleam, will remain just out of reach. Among the wind-scoured plains of Mars, certain formations have sparked debates that blur the line between geology and archaeology. High-resolution images from orbiters like MR-RO reveal clusters of angular, linear features stretching across the landscape, some arranged in grids, others resembling toppled columns or fragmented walls. At a glance, they look hauntingly like the ruins of a long-lost city, complete with what appear to be crumbled foundations and right-angled intersections. It's impossible not to wonder, could these be the skeletal remains of an ancient Martian civilization, buried beneath millennia of dust? Geologists have a far less cinematic explanation. These so-called walls are likely examples of jointed bedrock, where tectonic stress or cooling lava has fractured rock into clean, geometric patterns. On Earth, we see similar formations in places like Giant's Causeway in Northern Ireland, or the hexagonal basalt columns of Devil's Postpile in California. Mars, with its history of volcanic activity and seismic shifts, would naturally produce such fractures, especially in regions like Niloceates Mensae or the labyrinthian Noctis labyrinthus, where the crust has been stretched and shattered over eons. Wind erosion then exaggerates these cracks, smoothing edges and leaving behind what looks like deliberate masonry. But the ancient ruins theory persists, fueled by striking examples like the Martian Formation, a circular arrangement of slab-like rocks that eerily mirrors Neolithic stone circles on Earth. Independent researchers have superimposed terrestrial ruin layouts onto these Martian features, pointing out alignments that seem too precise for chance. Some even argue that the walls follow mathematical ratios found in Earth's ancient architecture, like the golden section. Could these patterns hint at a shared architectural language across planets? Here's where Occam's razor slices through the speculation. While it's thrilling to imagine Martian architects, the simpler explanation that nature, given enough time and the right conditions, can mimic human design fits all available evidence. Mars lacks the telltale markers of construction, like mortar residues or tool marks. Its walls also lack consistency. Some angles are crisp, others uneven, unlike the standardized masonry of human ruins. Even the Martian arrangement can be explained by boulders tumbling into a depression and settling into a ring, much like Antarctica's drunken forests of ice-heaved rocks. Yet the debate reveals something profound about how we explore alien worlds. When confronted with the unfamiliar, our brains reach for the nearest reference point. And on Mars, where every shadow could hide a secret, it's tempting to see the ghosts of builders in the rocks. These ruins may be geological, but their real power lies in what they say about us, our hunger to find kinship in the cosmos, even if it's just a pile of fractured basalt pretending to be a palace. So the next time you spot a wall on Mars, remember it's not just a rock. It's a mirror reflecting our own longing to believe that somewhere, even in ruins, we're not alone. And who knows, maybe one day we'll find a crack in Occam's razor, a line so fine it really was drawn by something other than the wind. In the cold, sun-baked soil of Mars, something peculiar keeps appearing. Clusters of small, rounded protrusions that look unsettlingly like mushrooms. Photographed by Curiosity and other rovers, these odd formations sprout from the ground in groups, their pale, bulbous caps and stubby stems, resembling Earth's puffball fungi or even lichen clinging to rocks. The images ignited a firestorm of speculation. Could these be the first tangible signs of life on Mars, hardy organisms eking out an existence in the planet's brutal environment? Skeptics point to a far less exotic explanation: hematite concretions, small mineral nodules that form when water deposits iron oxide around a central core. On Earth, we find similar blueberries in places like Utah's Morrison Formation, where groundwater percolated through ancient sediments. Mars, with its history of liquid water, could easily have produced these spherical formations through purely geological processes. Close-up analysis reveals their surfaces are pitted and rough, lacking the fine textures we'd expect from biological growth. The stems, just fragments of surrounding rock or clumps of debris caught in the wind. Yet not everyone is convinced. A controversial 2021 study led by researchers from the Journal of Astrobiology and Space Science Reviews made headlines by arguing the mushrooms exhibit behavior inconsistent with minerals. Using time-lapse rover images, they claimed the formations appeared to grow, change shape, and even resprout after dust storms, traits more reminiscent of living organisms than inert rocks. Some microbiologists noted similarities to Antarctic cryptoendolithic fungi, which survive by growing inside porous rocks. If Earth's deserts harbor such extremophiles, why not Mars? Mainstream science remains deeply skeptical. NASA geologists argue the perceived growth is likely optical illusions caused by shifting shadows or wind-blown dust. The resprouting could simply be fresh exposures of existing nodules as loose soil is stripped away. And while hematite concretions don't explain every anomaly, like the occasional branching patterns that look like mycelium, alternative theories like salt crystallization or iron-rich fluid seepage fill those gaps without invoking biology. The debate crystallizes a core challenge in astrobiology, distinguishing life from clever mimics. On Earth, we've found minerals that form filaments identical to bacterial colonies and silica deposits that mimic fossilized algae. Mars, with its alien chemistry and erosion patterns, could be a master of such deception. Until we retrieve samples or spot definitive biomarkers like chitin in fungal cell walls, the mushrooms will remain a Rorschach test. Are we seeing primitive life clinging to existence, or just another of Mars' geological pranks? Perhaps the most compelling argument against the fungal theory is the planet's relentless radiation. Without a thick atmosphere or magnetic field, Mars' surface is bombarded by cosmic rays and UV light, creating conditions lethal to most known organisms. But extremophiles have shattered our assumptions before. On Earth, life thrives in nuclear reactor cooling pools and acidic volcanic lakes. If Martian fungi exist, they might be subterranean, surfacing only during brief, favorable windows, a tantalizing but elusive target for future missions. For now, the mushrooms remain one of Mars' most provocative mysteries. They challenge us to question not just what we're seeing, but how we see it. After all, the line between life and non-life might be thinner than we think, and somewhere in those grainy rover images, nature could be playing the ultimate trick, leaving us to wonder if we're staring at rocks. Or something waiting to be recognized. Among Mars' countless oddities, few are as mind-bending as the so-called floating rocks, boulders that appear to hover centimeters above the ground, defying gravity itself. The Curiosity rover first spotted these perplexing formations in the Glen Torridon region, where several football-sized rocks seemed suspended in mid-air, their shadows oddly detached from their bases. Internet sleuths pounced, declaring everything from alien anti-gravity tech to glitches in the Martian matrix. But the truth, as always on Mars, is a masterclass in how alien environments can fool human perception. The secret lies in two factors working in tandem: Mars' low gravity and the rover's camera angles. With just 38% of Earth's gravitational pull, rocks on Mars can balance on surprisingly narrow pedestals of eroded sediment without toppling. When viewed from certain perspectives, especially the rover's downward-facing mast cameras, these slender supports become invisible, hidden by the rock's own shadows or blending into the terrain. It's the same illusion that makes a magician's levitation trick convincing. Hide the stand and the object appears to float. On Earth, wind and rain would quickly wear down such delicate formations, but Mars' gentler erosion preserves them for millennia, turning the landscape into a gallery of natural sleight of hand. Scientists have even recreated the phenomenon in labs using Martian soil simulants and low-pressure chambers. By replicating the planet's conditions, they've produced identical floating rocks, proving geology alone can explain the mystery. Some formations owe their levitating appearance to ventifacts rocks sandblasted into mushroom-like shapes where the narrow base erodes faster than the wider top. Others perch on pedestals of hardened sediment that resist weathering while surrounding softer material blows away. But the floating rock debate reveals something deeper about how we interpret Martian imagery. Our brains are wired for Earth-like physics, where heavy objects don't balance on toothpick-thin stems. Mars constantly challenges these assumptions, offering glimpses of a world where the rules feel familiar yet play out differently. Those hovering boulders aren't just geological quirks, they're reminders that the red planet operates on its own terms. And sometimes the most alien discoveries are simply nature showing us a trick we hadn't seen before. Jutting from the rusty plains of Mars-Phobos region, a single slab of rock stands in stark defiance of the surrounding chaos, a near-perfect rectangular block, its edges so unnervingly straight, it could have been lifted from the set of 2001, A Space Odyssey. Discovered in 1998 by NASA Mars Global Surveyor, this so-called monolith towers roughly 5 meters tall, casting a long geometric shadow across the dust. From the moment the images reached Earth, the parallels to Arthur C. Clarke's fictional alien marker were impossible to ignore. Was this a cosmic coincidence or something more deliberate? Geologists point to a well-documented earthly process to explain the monolith's origins: columnar jointing. When thick layers of molten rock cool slowly, they contract and fracture into angular pillars, often hexagonal but sometimes rectangular. Iceland's Giant's Causeway and California's Devil's Postpile are stunning examples of nature's stonemasonry at work. On Mars, where ancient lava flows once blanketed vast regions, similar forces could easily carve such a block, especially if the cooling process was uneven or the basalt composition varied. Wind erosion would then isolate the formation, leaving it standing like a solitary sentinel, but the monolith's precision unnerves even seasoned scientists. Independent analysts have measured its proportions, noting the sides align almost exactly at 90-degree angles, a rarity in natural formations. Some argue that Phobos, Mars' tiny moon where the monolith was spotted, lacks the geological activity to produce such a feature. Could it be debris from an impact or even a fragment of an ancient spacecraft? The most provocative theory, championed by astronaut Buzz Aldrin in a 2009 interview, suggests the monolith might be an artificial marker, a billboard, as he put it, left by an advanced civilization to draw attention to Phobos' strange orbit, which some claim is artificially maintained. The debate taps into a deeper tension in how we explore the cosmos. Monoliths, whether in fiction or on Phobos, represent the unknown calling to us, a silent challenge to investigate further. They embody the hope that the universe might not just be a collection of random rocks, but a place with signposts waiting to be read. NASA's proposed Phobos Surveyor mission, designed to study the moon's origins, could finally settle the argument. Until then, the monolith remains a Rorschach test. Is it a geological fluke or a nod from the stars? Perhaps the most compelling lesson here isn't about aliens, but about human curiosity. We're hardwired to see intention in symmetry, to find meaning in the angular and the ordered. The monolith fascinates not because it must be artificial, but because it could be. And on a world like Mars, where every shadow hides a mystery, that's enough to keep us looking up, wondering. In the dusty wastelands of Mars' Gale crater, the Curiosity rover rolled to a stop in 2014, its cameras locking onto something that made headlines worldwide, a rock so eerily shaped it looked like a fossilized alien skull. With hollow eye sockets, a protruding nose bridge, and even what appeared to be a jagged jawline, the formation ignited a firestorm of speculation. Had we finally stumbled upon the remains of a Martian creature, its bones turned to stone over millions of years, scientists quickly stepped in with a sobering reality check. This was pareidolia in action, the same mental shortcut that makes us see faces in clouds or animals in passing shadows. The skull was nothing more than a wind-sculpted rock, its haunting features carved by centuries of abrasive Martian gusts. On Earth, we find similar formations, from New Mexico's kissing camels to Australia's wave rock, where erosion transforms ordinary stone into uncanny imitations of life. Mars, with its relentless dust storms and thin atmosphere, is a master of this illusion, turning random cracks and angles into something our brains insist on recognizing. But here's why this particular rock matters beyond the viral hype. NASA deliberately uses these pareidolia moments as teaching tools. Every time a rover snaps an image of a face, spoon, or skull, it sparks a public conversation about how science separates signal from noise. Researchers highlight the differences between geological weathering and true biosignatures, like the way wind carves smooth curves, while biological structures often exhibit microscopic textures or chemical imbalances. The alien skull, for example, lacks the cellular patterns or isotopic signatures that would hint at once living tissue, yet the debate doesn't end there. Some conspiracy theorists argue that scientists dismiss these anomalies too quickly, pointing to Earth's own history of misidentified fossils. The early 20th century Piltdown Man, a hoax cobbled from human and orangutan bones, proved even experts can be fooled by clever forgeries. Could Mars be hiding its own Piltdown moments not as hoaxes but as genuinely ambiguous formations? It's a question that keeps astrobiologists up at night, especially as missions like Perseverance sift through sediments for microfossils. The skull's legacy isn't about proving or disproving life on Mars. It's about the tension between human intuition and scientific rigor. We're wired to seek familiarity in the unknown, to find faces in the dark. But Mars, with its silent, wind-scoured plains, constantly reminds us that nature doesn't need life to create the illusion of it. And while we might never find a real Martian skull, the search itself, learning to question what we see, is what propels us forward. After all, the day we stop seeing skulls in the rocks might be the day we miss the real thing. Mars isn't just a desert, it's a desert with ghosts. Stretching across its rusty plains are the skeletal remains of river valleys, their dry channels etched into the landscape like scars from a lost age of water. These ancient riverbeds, some wider than the Grand Canyon and hundreds of miles long, tell a story of a world that once rippled with rivers, gushed with floods, and maybe, just maybe, teemed with life. When orbiters like MRO map these networks in stunning detail, the implications are staggering. This wasn't just a damp Mars, it was a soaked Mars, crisscrossed by waterways that might have rivaled Earth's mightiest rivers. The evidence is written in the rocks. Take Nandi Valles, a sinuous canyon stretching over 500 miles with meandering curves so precise they look drawn by a celestial cartographer. Or Athabasca Valles, where catastrophic floods, possibly unleashed by underground ice melting in volcanic heat, scoured the land with such force they left behind teardrop-shaped islands and plunge pools eerily similar to those in Earth's channeled scablands. These aren't just random gullies, they're textbook examples of water's handiwork, complete with tributaries, deltas, and even smoothed pebbles that rovers like Curiosity have rolled past. But here's where the mystery deepens. Some of these channels are too perfect, their geometry so precise, a few researchers have dared to ask, could something else have carved them? On Earth, rivers wiggle and branch organically, shaped by vegetation, soil types, and rainfall patterns. But certain Martian valleys, like those in the Lyot crater, run in unnervingly straight lines with angular junctions that seem almost engineered. Independent hydrologists have noted that some networks resemble man-made irrigation systems from ancient Mesopotamia or the dendritic patterns of mining drainage. Could these be remnants of a long-dead civilization's waterworks? Mainstream science, of course, points to Mars' unique geology. Without plate tectonics to recycle its crust, the planet preserves ancient features for billions of years, allowing wind and occasional liquid water to sculpt the land with unnatural-seeming precision. Then there's the role of groundwater sapping, a process where seeping water undercuts cliffs, creating cleaner, straighter valleys than surface runoff. Even the angular channels might trace back to fractures in the Martian crust, where water followed pre-made fault lines like a train on rails. Yet the debate won't die, and for good reason. If Mars once had lush river valleys, where did all that water go? Some seeped underground, forming icy aquifers we're just beginning to detect. Some escaped into space, stripped away by solar winds as Mars' magnetic field sputtered out. But the sheer volume suggested by these channels hints that traces might remain locked in glaciers, buried lakes, or even clinging to mineral lattices. Every dry riverbed is a clue, a whisper of a time when Mars wasn't red but blue, and if water flowed there once, who's to say it didn't nurture life? The answer might lie in those parched valleys, waiting for us to read the stories written in their dust. Mars holds its breath, then exhales unpredictably. That's the puzzling reality of the planet's methane spikes, a mystery that has scientists oscillating between excitement and frustration. Since Curiosity first detected sporadic bursts of this gas in 2013, these fleeting whiffs, sometimes vanishing within hours, have defied easy explanation. On Earth, methane is often a calling card of life, belched by cows, bubbling from swamps, or leaked by microbes deep underground. Finding it on Mars raises the electrifying question, could something alive still be stirring beneath that barren surface? The data paints a curious pattern. methane concentrations in Gale crater occasionally soar to 10 times background levels before plummeting back to near zero. These aren't steady leaks but sudden, localized surges, as if the planet itself is flickering between secrecy and revelation. Even more baffling, Europe's Trace gas orbiter, designed specifically to sniff methane from above, has mostly come up empty, suggesting the gas disperses or vanishes almost as quickly as it appears. The disconnect between rover and orbiter readings adds layers to the mystery. Is the methane being destroyed by atmospheric chemistry, or are we seeing pockets of emission too small for orbiters to spot? Scientists have two leading suspects. The first is geology, specifically serpentinization, a process where water reacts with certain minerals like olivine, releasing methane as a byproduct. Mars' crust is rich in these minerals, and if liquid water still lurks in underground aquifers, the reaction could be chugging along unseen. The other, far more tantalizing possibility involves methanogens, primitive microbes that thrive in airless, waterlogged places on Earth. Mars' subsurface, shielded from radiation and possibly warmed by geothermal heat, could harbor similar extremophiles, their metabolic processes puffing out methane like microscopic steam engines. Yet every clue comes with caveats. Serpentinization requires ongoing water-rock interactions, but no mission has definitively proven liquid water exists deep below Mars today. Meanwhile, the microbial hypothesis hinges on a leap of faith that life not only arose on Mars but persists in isolated pockets, defying odds that would obliterate most Earth organisms. Even if the methane is abiotic, its transient nature suggests an active, dynamic Mars where gases are being produced, trapped, and released in ways we don't yet understand. The stakes couldn't be higher. Methane is famously fragile, broken apart by ultraviolet light within centuries. Its presence implies a recent or ongoing source, whether biological or geological. Future missions like the Mars Life Explorer aim to drill deeper literally into this enigma, analyzing isotopes in the gas for telltale signatures of life. Certain carbon isotopes, for instance, are favored by biological processes, offering a potential fingerprint. Until then, the methane spikes remain a maddening riddle, one that keeps the door ajar for the most extraordinary possibility of all, that in the silent dark beneath Mars' sands, something is still breathing. Mars doesn't just whisper, it howls. Among its most mesmerizing displays are the towering dust devils, twisting columns of wind that snake across the barren plains like phantom tornadoes. These whirlwinds, some reaching heights of 5 miles, are far more than just atmospheric quirks. They're dynamic, destructive, and sometimes downright helpful, scrubbing dust from solar panels to keep our robotic explorers alive. The science behind these swirling spectacles is as fascinating as their appearance. Dust devils form when the sun heats the Martian surface, creating pockets of warm air that rise rapidly through cooler layers above. As the air spirals upward, it picks up fine grains of dust, spinning them into towering vortices that can last for minutes or even hours. Unlike Earth's dust devils, which rarely exceed a few hundred feet, Mars' low gravity and thin atmosphere allow these whirlwinds to grow to staggering heights, some wider than football fields. One of the most striking examples was captured by the Spirit rover in 2005, when it filmed a dust devil nearly half a mile high marching across Gusev crater. The footage revealed a ghostly funnel twisting with such force it kicked dust high into the air, leaving behind serpentine tracks on the surface. For scientists, these tracks are more than just scars, they're clues. By studying their paths and frequency, researchers can map wind patterns and even estimate the age of surface features based on how quickly dust devils erase them. But the real magic lies in their unintended kindness to our robotic explorers. Mars' pervasive dust is a silent killer for solar-powered missions, gradually coating panels until they can no longer generate electricity. That's where dust devils step in literally. Both Spirit and Opportunity experienced miraculous cleaning events where passing whirlwinds scoured their panels, boosting power levels overnight. In 2009, Opportunity's energy output surged by over 10% after a particularly vigorous dust devil danced across its solar arrays. It's as if Mars itself occasionally lends a hand, sweeping away the red grit to give our machines a second wind. Yet dust devils aren't just scientific tools, they're windows into Mars' turbulent soul. Their behavior hints at atmospheric pressures, seasonal changes, and even subsurface conditions we can't yet measure directly. Some researchers speculate that these whirlwinds might loft microbes or organic material high into the air, spreading them across the planet like cosmic pollinators. Others warn that future human habitats will need to withstand their abrasive power, which can sandblast equipment or erode structures over time. Whether saviors or saboteurs, dust devils embody Mars' restless spirit. They're reminders that even in stillness, the planet is alive with motion, a world where the wind doesn't just blow but dances, leaving behind trails of questions in the dust. And as we watch them spiral across the horizon, we're left to wonder, what other secrets might they carry on their whirlwind journeys? Deep beneath Mars' frozen South Pole, a discovery sent shockwaves through the scientific community, bright radar reflections that seem to reveal not just ice but liquid water. The European Space Agency's Mars Express orbiter first detected these anomalous signals in 2018, spotting a 20-kilometer-wide patch beneath layered ice where radar waves bounced back with unexpected intensity. On Earth, such readings almost always indicate subglacial lakes, like those found beneath Antarctica's kilometers-thick ice sheets. The implications were staggering. If liquid water existed on Mars today, it could rewrite the odds for finding life beyond our planet. But science thrives on skepticism, and soon alternative explanations emerged. The leading counterargument points to smectite's clay minerals loaded with water molecules bound tightly in their structure. When exposed to radar, certain clays can produce reflections nearly identical to liquid water. Mars' polar regions contain vast deposits of these minerals, leftovers from a wetter past when groundwater percolated through the soil. Could the lakes simply be layers of hydrated clay, frozen solid yet still mirroring radar like their liquid counterparts? Proponents note that Mars' average surface temperature hovers around -60°C, far too cold for pure water to remain liquid, even under pressure. Yet the lake advocates hold firm. They argue that the reflection's intensity and sharp boundaries match terrestrial subglacial lakes too closely to dismiss. Crucially, the suspected reservoir lies beneath the Ultimae Scopuli ice formation, where pressures from the overlying ice sheet could lower water's freezing point. Add in dissolved salts like magnesium perchlorate known to exist in Martian soil, and you've got a potential brine stew, viscous and slushy but technically liquid. Some models suggest geothermal heat from ancient volcanic activity might still warm the depths enough to maintain these pockets, creating isolated oases in the cryogenic desert. The debate took a twist in 2021 when follow-up studies claimed to identify multiple smaller lakes surrounding the main one, forming what looked like a subterranean network. But critics highlighted inconsistencies. Why did some patches appear at varying depths, defying expectations for a continuous aquifer? Others noted that the Mars Advanced Radar for Subsurface and Ionosphere sounding Mars's instrument wasn't originally designed for such precise subsurface mapping, leaving room for data artifacts. The stakes couldn't be higher. If the lakes are real, they'd be the first stable liquid water bodies ever confirmed beyond Earth, a potential sanctuary for microbial life. Antarctica's Lake Vostok, sealed under ice for 15 million years, teems with unique bacteria. Could Martian microbes, if they ever existed, have retreated to similar refuges as their world dried out? Future missions like NASA's Mars Life Explorer, designed to drill into polar ice, might finally settle the argument. Until then, those enigmatic radar blips remain a Rorschach test reflecting either the whisper of hidden seas or the echo of a long-lost wet Mars frozen in time. Perhaps the most profound lesson lies in what the controversy reveals about exploration itself. Mars never serves up easy answers. Just when we think we've pinned it down, it offers a tantalizing maybe, a shadow of liquid where none should exist, a glimmer of possibility in the data. Whether lakes or clays, the South Pole's secrets remind us that the universe reserves its greatest truths for those willing to sit with uncertainty, to keep probing the faint signals in the dark. Every year, Mars puts on a vanishing act that would make even the greatest magicians envious. Its polar ice caps, massive sheets of frozen carbon dioxide, disappear before our eyes as the seasons change. Captured in stunning detail by orbiters like the Mars Reconnaissance Orbiter, this seasonal dance reveals a world in constant transformation. One moment, vast stretches of the poles gleam with thick layers of CO2 ice. The next, they've retreated like ghosts into the thin Martian air. The science behind this spectacle is sublimation, the process where ice skips the liquid phase entirely, turning directly from solid to gas under Mars' low atmospheric pressure. On Earth, we see this when dry ice vanishes into fog, but on Mars, it happens on a planetary scale, with entire ice sheets vanishing in a matter of months. Yet not every detail fits neatly into the textbook explanation. Some observers point to anomalies, areas where the ice vanishes too quickly, or in patterns that don't match predicted sublimation rates. In certain regions, the ice retreats in geometric shapes, almost as if following an unseen grid. These oddities have fueled wild speculation, with conspiracy theorists proposing everything from hidden underground heat sources to deliberate manipulation by advanced technology. Could something or someone be accelerating the melt? The truth is likely far stranger than fiction. Scientists suspect these irregularities stem from variations in ice thickness, dust coverage, and even wind patterns. Dark dust sprinkled on the ice absorbs more sunlight, speeding up sublimation in uneven patches. Meanwhile, Mars' notorious whirlwinds can scour the surface, exposing fresh ice to the sun's rays and creating those puzzling geometric retreats. But the most tantalizing possibility involves underground features, hidden cracks or thermal vents that might locally boost temperatures, causing the ice above to vanish faster than expected. What makes this phenomenon so mesmerizing isn't just the science or the conspiracies, it's the reminder that Mars is a world of cycles of constant change. Those vanishing ice caps aren't just frozen carbon dioxide. They're clocks ticking through the seasons, telling a story of a planet that's far from dead. And while we may never find alien engineers melting the poles, the real mystery, how such a seemingly simple process can produce such complexity, is captivating enough on its own. After all, nature doesn't need a helping hand to perform miracles. Sometimes it just needs a little sunlight and time. Mars doesn't just lack a magnetic field, it wears its fractured history like a scarred warrior. Unlike Earth's strong, planet-encasing magnetic shield, Mars sports only scattered patches of magnetism, concentrated mostly in the southern highlands. These ghostly remnants, detected by orbiters like Mars Global Surveyor, form bizarre striped patterns across the terrain, alternating bands of strongly and weakly magnetized crust stretching hundreds of miles. This patchwork quilt of magnetism tells a story of catastrophe, of a world that once thrived with protection and lost it in a cosmic tragedy. Billions of years ago, Mars likely boasted a robust global magnetic field, generated by a churning molten core just like Earth. That field acted as an invisible force field, deflecting deadly solar radiation and allowing the planet to maintain a thicker atmosphere. Then something went terribly wrong. Geological evidence suggests Mars' core cooled rapidly, possibly due to the planet's smaller size losing heat faster. Without the dynamo effect of a swirling molten core, the magnetic field collapsed like a dying star. The consequences were apocalyptic. Stripped of its protective shield, Mars' atmosphere was slowly torn away by solar winds, turning the planet into the frozen desert we see today. But here's the twist. Those surviving magnetic patches refuse to fit neatly into the narrative. Their striped patterns resemble the magnetic stripes on Earth's seafloor, where tectonic activity constantly generates new crust. This bizarre similarity has led some scientists to propose that early Mars experienced plate tectonics, with crustal movements imprinting these magnetic signatures before the dynamo shut down. Others argue the patterns stem from massive asteroid impacts that melted portions of the crust, allowing minerals to realign with the last flickers of the dying magnetic field. Each theory carries staggering implications. If plate tectonics existed on Mars, it could mean the planet was even more Earth-like than we imagined, with shifting continents and volcanic recycling that may have nurtured life. The most haunting question remains: why did these patches persist when the global field vanished? Some minerals, like magnetite, can lock in magnetic orientation like a cosmic snapshot, preserving the field's direction at the moment they cooled. But the intensity of these anomalies puzzles researchers. Certain regions, like the Terra Cimmeria highlands, exhibit magnetism 10 times stronger than anything on Earth's surface. Could there still be localized magnetic activity deep below, some last gasp of a dying core? Recent seismic data from NASA in Sightlander revealed surprising core dynamics, a molten layer larger than expected, hinting that Mars' interior might not be as dead as we thought. As we piece together this magnetic mosaic, every discovery raises new enigmas. The patches might explain why certain areas of Mars have thinner atmospheres than others. The stronger magnetic zones could still deflect solar particles, creating uneven erosion. They might also influence where future astronauts could safely land, as regions with residual magnetism could offer partial radiation shielding. But perhaps their greatest gift is the window they provide into planetary mortality. Mars is the only world besides Earth where we've found such clear evidence of a past magnetic field, making it a cautionary tale for what happens when a planet's heart stops spinning. As we study these magnetic ghosts, we're left to wonder, was Mars' fate inevitable, or could something have saved it? And in those lingering patches, is there a whisper of hope that one day, somehow, a planet's magnetic heartbeat might be restarted? The answers lie buried beneath the rust-colored soil, waiting for us to listen. Stretching across Mars' windswept plains like veins of molten glass, the planet's mysterious tunnels present one of its most visually striking and hotly debated features. These smooth, sinuous tubes, some as wide as highways and stretching for miles, gleam under the Martian sun with an almost unnatural polish. Their surfaces appear fused, as if scorched by unimaginable heat, leaving behind hollow conduits that snake through the terrain like the remnants of some gargantuan lava slide. To scientists, they're fascinating geological artifacts. To conspiracy theorists, they're potential proof of extraterrestrial engineering. The truth, as always on Mars, lies somewhere between the mundane and the mind-bending. The leading scientific explanation points to volcanic processes. When lava flows across a surface, the outer layer cools and hardens first, forming a crust while molten rock continues to surge beneath. Once the eruption ends, the lava drains away, leaving behind empty tubes, nature's version of piping. On Earth, we see smaller versions in Hawaii's Kazumura Cave or Iceland's Circular. But Mars, with its ancient megavolcanoes like Olympus Mons and lower gravity, could have produced tubes of staggering scale. Some estimates suggest these tunnels might reach hundreds of feet in diameter, dwarfing anything on our planet. The glassy sheen, likely the result of rapid cooling or mineral-rich lava that formed a natural obsidian-like glaze, yet certain details defy easy classification. Some tubes exhibit segments so perfectly cylindrical, they resemble precision-engineered corridors rather than chaotic natural formations. Others branch at near-perfect right angles, a rarity in volcanic systems where lava typically follows the path of least resistance. These oddities have fueled speculation that the tunnels might be remnants of colossal impact melts, where meteor strikes liquefied the surface, creating rivers of molten rock that hardened into tunnels as they cooled. The Rochechouart crater in France offers a terrestrial parallel with similar glassy veins forged by asteroid impacts. Then there's the fringe theory that refuses to die, the idea that these tunnels aren't natural at all. Some researchers point to their unnervingly uniform widths and smooth interiors, suggesting they could be the remnants of an ancient transportation network, a Martian subway carved by advanced machinery or even melted by directed energy weapons. The most vocal proponents highlight tunnels that appear to connect geological hotspots or align with other alleged structures, as if part of a planned system. Skeptics counter that wind erosion and dust infill can artificially smooth surfaces over millennia, while the human eye tends to impose order on randomness. The real intrigue lies in what these tunnels could mean for future exploration. Their hollow interiors, shielded from radiation and temperature swings, make them prime candidates for human habitats or microbial refuges. Scientists have even proposed sending autonomous drones to map their depths, searching for signs of water ice or organic compounds trapped in the glassy walls. Private ventures like SpaceX have floated the idea of pressurizing these tunnels as ready-made bases, their natural arches offering sturdy protection against cosmic rays and dust storms. Whether born of fire, impact, or something far stranger, Mars glass tunnels are more than geological curiosities. They're time capsules. Each one holds clues to the planet's violent past, its lost oceans of magma, and the forces that shaped a world simultaneously familiar and alien. And until we peer inside their shadowy depths, they'll remain a canvas for our boldest theories and quietest wonders, reminding us that some mysteries can't be solved from orbit, only by stepping into the dark. Picture this, a cold, still evening on Mars, the red dust settling as the InSight lander sits silently on the Elysium Planitia. Then, suddenly, the darkness is pierced by something unexpected, a faint, ghostly whistle rising and falling like a distant howl through a canyon. This isn't science fiction, it's real audio captured by InSight's sensors in 2019, a haunting soundscape that sent chills down spines and sparked a frenzy of speculation. Were we hearing the whispers of Martian winds or something far more unsettling? The science behind these eerie noises is both simple and profound. InSight's seismometer, designed to detect Mars squawks, inadvertently became an interstellar microphone. As Martian winds sweep across the lander's solar panels at speeds of up to 35 miles per hour, they cause vibrations that resonate through the spacecraft's structure. These vibrations are converted into sound waves, creating what scientists call aeolian tones, the same phenomenon that makes telephone wires hum or canyon walls sing on Earth. But Mars' thin atmosphere, just 1% as dense as ours, alters the sound dramatically, stretching and distorting it into something otherworldly. The result, a symphony of creaks, rattles, and yes, those unmistakable whistles, all amplified by the planet's eerie silence. Yet when these recordings reached the public, not everyone heard just whine. Some listeners swore they detected patterns, repetitive pulses, almost rhythmic as if coded. Conspiracy forums lit up with theories. Were these signals from underground bases? Alien communications bouncing off the lander. Even scientists admit the sounds can play tricks on the mind. The human brain is wired to find meaning in noise, a survival trait called apophenia. It's why we hear voices in static or see faces in clouds. On Mars, where every shadow feels like a secret waiting to be uncovered, it's all too easy to mistake the wind's random wails for something intentional. What makes these sounds so compelling isn't just their mystery, it's what they reveal about Mars itself. Unlike Earth, where sound is muffled by thick air, Martian noises carry with an eerie clarity, their frequencies unobscured. Future astronauts might experience this firsthand, hearing the crunch of their boots echo unnaturally or the whir of a rover's motors travel for miles. The whistle, then, isn't just a curiosity, it's a preview of how alien even the most familiar sounds will become on another world. So is the Mars whistle a message, a mistake, or just the wind? Science leans firmly toward the latter, but the debate endures because it taps into something deeper. In that static, we're not just hearing vibrations, we're hearing the voice of Mars itself, a world that refuses to be silent. And whether it's whispering secrets or simply sighing through the dust, one thing's certain: the red planet will always keep us listening. Mars' thin air holds a secret that defies explanation: oxygen levels that rise and fall without any clear reason. Since 2012, NASA Curiosity rover has been meticulously measuring the planet's atmosphere, and the data has left scientists scratching their heads. Unlike the steady, predictable mix of gases found on Earth, Mars' oxygen behaves erratically, spiking unpredictably in spring and summer before dropping back to expected levels in winter. The fluctuations are small but significant, with oxygen concentrations increasing by up to 30% before crashing back down. No known chemical process on Mars can fully account for these swings, leaving researchers to wrestle with an unsettling question: could something alive be altering the air? The chemical explanations are intriguing but incomplete. One leading theory suggests that perchlorate salty compounds abundant in Martian soil could be breaking apart and releasing oxygen when exposed to sunlight or heat. On Earth, similar reactions occur in extreme environments like Chile's Atacama Desert, where soil chemistry produces trace gases. But Mars' oxygen spikes don't align neatly with temperature or UV radiation changes, leaving gaps in the theory. Another idea points to hydrogen peroxide, a compound once speculated to exist in Mars' atmosphere, which could decompose into water and oxygen. Yet no mission has detected enough hydrogen peroxide to explain the rover's readings. Then there's the elephant in the room: biology. On Earth, oxygen fluctuations are often the fingerprint of life: photosynthetic microbes inhaling carbon dioxide and exhaling oxygen in rhythmic cycles. Could hardy Martian organisms buried just beneath the surface be doing something similar? The seasonal peaks match patterns seen in microbial ecosystems on Earth, where activity surges during warmer months. Even more tantalizing, the oxygen spikes sometimes coincide with methane fluctuations, another gas often linked to biological activity. It's a provocative possibility, but skepticism runs deep. Without direct evidence like microbial cells or metabolic byproducts, the biological explanation remains a speculative long shot. The mystery deepens when considering alternative sources. Some scientists propose that oxygen might be trapped in porous rocks or ice, released slowly as temperatures rise. Others wonder if high-energy cosmic rays could split water molecules in the soil, freeing oxygen atoms to escape into the air. But each of these theories struggles to explain the timing and magnitude of the variations. Even more puzzling, the oxygen spikes aren't consistent year after year, adding another layer of complexity to an already confounding puzzle. What makes this enigma so compelling isn't just the lack of answers, it's what those answers could reveal about Mars' hidden dynamics. If the cause is chemical, it points to unknown geological processes that could reshape our understanding of the planet's subsurface chemistry. If it's biological, even in some indirect way, it would be the most profound discovery in human history. For now, Curiosity's data sits like a cipher waiting to be decoded, a reminder that Mars still guards its secrets closely. Every erratic breath of oxygen is a whisper daring us to listen closer, and until another mission can peer deeper into the soil or the skies, that whisper will keep us guessing, wondering, and dreaming of what might be stirring in the thin, red air. Mars doesn't just have cracks, it has scars that turned into jewelry. Stretching across its ancient plains are networks of zigzagging ridges, their angular paths crisscrossing the landscape like the seams of a colossal, shattered vase. These polygonal formations, some stretching for miles, glow pale against the rusty soil, their edges sharp enough to cast long shadows from orbit. At first glance, they look almost artificial, like the remnants of abandoned roads, irrigation channels, or even the outlines of some long-lost farming grid. But the truth behind these ridges is a story written in water, time, and the stubborn persistence of stone. Scientists believe these zigzags began as cracks in Mars' wet past. Billions of years ago, when the planet's surface was still soaked with water, seasonal freezing and thawing, or the drying of muddy sediments split the ground into geometric fractures. These cracks, like the patterns in a drying desert lakebed on Earth, formed a honeycomb of polygonal shapes, but here's where Mars adds its own twist. Over time, mineral-rich groundwater seeped into these fractures, depositing hardier materials like silica or iron oxides. When the softer surrounding rock eroded away, the hardened fillings remained, standing proud as elevated ridges. It's nature's version of lost wax casting, where the mold is destroyed to reveal the sculpture inside. Yet not all ridges fit this neat explanation. Some formations, like those in the Medusae-Fossae region, exhibit bizarrely uniform angles, their intersections too precise to dismiss as random. A few researchers have pointed to their resemblance to terrestrial fossilized mud cracks, but others note key differences, especially the scale. On Earth, such patterns might span a few meters. On Mars, they can stretch for kilometers, suggesting processes amplified by the planet's lower gravity and ancient climate extremes. Then there's the eerie similarity to human-made structures. The ridges near Antoniadi crater, for instance, align in grids that mirror agricultural terracing or the foundations of buried buildings, fueling speculation about ancient Martian farming or even construction. The myth of ancient farming gained traction when fringe theorists superimposed images of these ridges onto aerial photos of Neolithic field systems in places like Ireland or Peru. The visual parallels are striking, but science cautions against mistaking resemblance for reality. Mars lacks the layered evidence of cultivation: no seed fossils, no tools, no stratified soil amendments. Instead, the ridge's chemistry tells a different tale. Spectrometers aboard orbiters like MR-RO have detected hematite and sulfates in these formations, minerals linked to hydrothermal activity or acidic water, not the fertile loam of farmland. What makes these zigzags truly mesmerizing isn't just their origin, but their endurance. While Mars' rivers vanished and its lakes froze, these ridges stood firm, silent witnesses to the planet's dramatic drying. They're more than geological quirks, they're time capsules, preserving a record of wetter days in their mineral bones. Future missions might drill into their hardened cores, searching for microscopic bubbles of ancient water or even traces of microbial life that once thrived in those crack-bound channels. So the next time you see those labyrinthine ridges, remember, they're not the ruins of a lost civilization, but something equally wondrous, a fossilized snapshot of a world in transition where water's last acts were etched in stone. And in their jagged lines, Mars whispers a lesson about impermanence, showing how even the mightiest forces can leave behind nothing more than a brittle, beautiful skeleton. Mars hides its ghosts in plain sight, not as specters, but as haunting imprints of what once was. Scattered across its deserts are thousands of crescent-shaped depressions, their curved walls rising like crumbling ramparts. These are the ghost dunes, eerie negatives of towering sand formations that vanished billions of years ago. Unlike Earth-shifting dunes, these Martian relics were frozen in time through an extraordinary act of planetary preservation, first buried by lava or sediment, then exposed again as the softer material around them eroded away. The result, hollow molds of ancient wind-sculpted giants, their inverted forms standing as tombstones for a lost era of Martian weather. The process that created these ghosts reads like a geological thriller. Imagine a massive dune field, some dunes stretching hundreds of feet tall, shaped by relentless winds under a thicker ancient atmosphere. Then catastrophe strikes. A volcanic eruption spews molten rock across the landscape, or sudden floods dump layers of wet sediment. The dunes become entombed, their surfaces encased like insects in amber. Over eons, wind or water strips away the surrounding material, but the dune's shape remains protected inside its hardened shell. Eventually, even the shell wears thin, collapsing inward to reveal the hollow cavity where sand once swirled. What's left is a precise cast of the dune's downwind face, its steep slope and curved crest preserved in stunning detail like a fossilized footprint, but for an entire mountain of sand. Scientists call these formations ghosts, not just for their hollow nature, but for the clues they whisper about Mars' lost environment. The orientation of their crescent horns reveals ancient wind directions, proving the planet's atmosphere once had enough density to sculpt such colossal dunes. Their size, some over 200 feet tall, suggests winds sustained over millennia, not the fleeting gusts of today's wispy air, and their distribution paints a picture of a dynamic world where dunes marched across basins now silent and dry. In the Nochi's Terra region, clusters of ghost dunes even overlap like waves frozen mid-collision, capturing snapshots of how these giants migrated across the landscape. But the real magic lies in what these ghosts protect. Inside some casts, rovers have detected minerals like opal or gypsum, hints that water once percolated through the buried dunes, leaving behind chemical signatures. A few show strange, spiral-like ridges along their walls, possibly evidence of microbial mats that grew in damp sands before their burial. Others contain layers of ash or dust, stratified like pages in a book recording ancient climate shifts. These features make ghost dunes more than geological curiosities. They're time capsules sheltering secrets from Mars' most habitable epoch. The most haunting question isn't how these ghosts formed, but why they're so abundant on Mars yet nearly absent on Earth. Our planet's tectonic restlessness and watery erosion rarely allow such delicate features to survive. Mars, with its stagnant crust and patient winds, preserves its past with museum-like precision. Every ghost dune is a monument to patience, a reminder that even the mightiest forces, given enough time, leave behind nothing but echoes in stone. And as we study their hollow curves, we're left to wonder, if the wind's handiwork can endure for eons, what other ghosts might be waiting, silent and unseen, beneath the dust? Mars doesn't just sleep when the sun sets, it breathes light. Unlike Earth's auroras, which dance in colorful ribbons near the poles, the red planet emits an eerie, uniform glow that envelops its entire night side. This phenomenon, known as the night glow, was first detected in ultraviolet by the European Space Agency's Mars Express orbiter, revealing a faint but unmistakable luminescence pulsing through the thin Martian atmosphere. Imagine standing on the surface at midnight, looking up to see the sky itself softly radiating, as if the planet is humming with invisible energy. The secret lies in a celestial chemistry experiment playing out 50 miles above the surface. During the day, ultraviolet sunlight tears apart carbon dioxide and nitrogen molecules, splitting them into individual atoms. As night falls and temperatures plummet, these free atoms descend through the atmosphere, colliding and recombining into nitric oxide molecules. But here's the twist. This recombination releases a burst of excess energy in the form of ultraviolet light. It's like watching cosmic Legos snap together, each connection letting off a tiny spark. On Earth, similar processes occur but are drowned out by our dense atmosphere or overshadowed by the brilliance of auroras. Mars, with its wispy air and lack of a global magnetic field, lets this glow shine unobstructed, painting the entire night sky in a spectral haze. What makes the night glow so fascinating isn't just its beauty, it's what it reveals about Mars' alien atmospheric rhythms. Unlike our planet, where auroras are driven by charged particles funneled along magnetic field lines, Mars' glow is a global exhale, a direct product of its atmospheric composition and brutal temperature swings. The glow's intensity varies seasonally, pulsing stronger during winter when the upper atmosphere cools and recombination accelerates. These fluctuations act as a barometer for atmospheric loss, hinting at how quickly Mars is shedding its already thin air to space. Yet mysteries linger. Some regions glow brighter than others, and the light occasionally flickers in ways models can't fully predict. A few scientists speculate that underground gases seeping through fractures might alter the chemistry, adding unaccounted ingredients to the nightglow recipe. Others wonder if dust storms, which inject particles high into the atmosphere, could be scattering the light or even catalyzing unusual reactions. Each unanswered question makes this phenomenon more than just a pretty light show. It's a cipher encoding secrets about Mars' past and future. The night glow also poses a tantalizing question for future colonists. Could this ultraviolet radiance, faint as it is, affect surface conditions or even potential agriculture? On Earth, auroras occasionally disrupt radio signals. Might Mars' glow interfere with sensitive equipment? And for those who one day stand under that shimmering sky, it will be a constant reminder. They're walking on a planet where even the darkness isn't truly dark, where the air itself remembers the sun's touch and answers with light. In the end, the night glow is more than atmospheric physics. It's a poetry of atoms, a silent testament to Mars' enduring dynamism. While the planet's surface lies frozen and still at night, its sky tells a different story, of molecules reaching for each other across the void, of energy never lost, just transformed. And as we watch this gentle radiance from orbit, we're left to wonder how many other unseen marvels whisper in the Martian dark, waiting for us to look closer. From the eerie face on Mars to the whispering winds caught by InSight, these 30 mysteries prove one thing: the red planet is a master of illusion and revelation. Just when we think we've pinned it down, Mars throws another curveball: vanishing methane, glassy tunnels that defy explanation, oxygen levels that dance to an unseen rhythm. Each discovery peels back a layer only to reveal another question beneath. The pyramids of Cydonia, the ghost dunes, the Martian blueberries, they're not just oddities. They're clues in the greatest detective story of our time, written in geology, chemistry, and maybe, just maybe, biology. What makes these enigmas so compelling isn't just the science, it's the tension between what we know and what we imagine. The human mind craves patterns, reaching for familiarity in the alien. That's why we see faces in rocks and cities in cracked terrain. But Mars keeps us honest, reminding us that nature's artistry often outstrips our fantasies. The line between pareidolia and revelation is razor thin. One moment we're debunking a crab monster as a shadow, the next we're staring at subterranean lakes that could rewrite the story of life itself. This dance between skepticism and wonder is where exploration thrives. Every rover image, every orbiter scan is a Rorschach test for our curiosity. Do we see a spoon or a geological marvel? A monolith or a fractured basalt column? The beauty lies in the debate, in the collective effort to separate signal from noise. And while science demands evidence, it also needs dreamers, those willing to ask what if. Because history shows us sometimes the wildest ideas spark the most profound discoveries. The next chapter of Mars' story is already being written. Missions like Mars Life Explorer will drill deeper, sniffing for isotopes that betray life's fingerprints. The Mars sample return could ferry rocks to Earth, holding secrets only labs here can unveil. And someday, human eyes will peer into those glassy tunnels, scale the ghost dunes, and feel the hum of the night glow overhead. Until then, the planet's mysteries remain open invitations, not just to solve but to savor. So stay curious. The universe rarely surrenders its secrets easily, and Mars least of all. Whether these puzzles are solved in years or centuries, one truth endures: the red planet isn't just a destination. It's a mirror reflecting our hunger to understand, our refusal to stop exploring, and our unshakable hope that somewhere in those rust-colored wastes, we might find the answer to the oldest question of all: are we alone? The search continues, and with every enigma, Mars whispers back, keep looking.